Welcome back to the History of Mathematics. In this video we are going to continue our work on the Euclidean algorithm. In our last video I gave a fairly straightforward example, so I'd like to give something that is a little more involved just to give you a feel for how this goes when you have to do more steps. So you'll remember that the Euclidean algorithm is a method for finding the greatest common divisor of two given numbers. So here what we're trying to do is we are trying to find the largest number that will divide into 341 and 527 evenly. And you'll remember the first step is to find the quotient and the remainder when we take 527 divided by 341. Now 341 goes into 527 one time, and let's see, it looks like there is 186 left over after we do that. So basically I needed to fill in these blanks, and it looks like 1 and 186 do the job. Now, as discussed in the last video, we kind of shift everything down. So we are taking 341 and we are figuring out the quotient and remainder, and 341 is divided by 186. So it looks like the quotient is once again 1, and it looks like there is, gosh, let me see here, 155 is our remainder. Okay, now we take 186, divide by 155, so we can see 155 goes in one time. Looks like there are 31. That 31 is our remainder. And now we take 155 and we divide that by 31. Okay, now this is going to go in 5 times with a remainder of 0. So getting that 0 remainder tells me I can stop my process. And right there, we'll remember that's my GCD. So the GCD of 341 and 527 is the last non-zero remainder that we got, which is 31. Now, another thing that I'd like to show you using the work that we just did is a way to express 31 as a combination of 341 and 527. So in other words, I want to find x and y so that 341x plus 527y equals 31. And if you remember, the steps that we performed in the Euclidean algorithm are what we use to figure out these numbers x and y. And the strategy was to rewrite each line so that it depends only on 341 and 527. So using the first line here, I'll just label these 1, 2, and 3. Okay, so by equation 1 becomes 186 equals 527 minus 341. Okay, we would subtract this over to the other side. Now, I'm going to substitute this expression on the right-hand side in for 186 in equation 2. So we're going to solve in equation 1 and we're going to sub into equation 2. So equation 2 becomes 341 equals, not 186, we're not going to write that, we're going to write 527 minus 341 plus 155. And we're going to do a little more rewriting here. 2 times 341 minus 527 equals 155. Okay, so you can see what I did here. I added 341 to both sides. and I subtracted the 527 to isolate this 155. Now, the reason that we're doing that is I'm going to take that and substitute that into equation 3 for 155. And we're going to substitute this in for the 186. Okay, so we're going to have to do two substitutions here. So equation 3 started out like such. It was 186 equals 155 plus 31. And we're going to do our substitutions here. So we have 527 minus 341 equals, and we're not going to write 155. We are going to write 2 times 341 minus 527. So, and then we've still got the plus 31 there. And now I want to isolate the 31. So remember, I want to write 31 as a combination of a multiple of 341 and a multiple of 527. And I've almost got it right here. All I need to do is get these terms over to the other side. That's easy enough. So let me see. If I collect terms, it looks like I got negative 3 times 341, because I would have to subtract this for both sides. And then I would add this over, so it would be plus 2 times 527, and that would leave the 31 over here on the right-hand side isolated. So I have found values of x and y that give me the result I'm looking for. If I use x equals negative 3 and y equals 2, then I get my linear combination of 341 and 527 that equals 31. And you can solve an equation like this in two variables if and only if this number over here is a multiple of the GCD of the two numbers that we have right here. So it's something you might actually prove in a course on number theory, let's say, but right now we'll just kind of state it as a fact. So this is another example of applying the Euclidean algorithm to find the GCD, and also using your work from the Euclidean algorithm to express the GCD as a linear combination of the two numbers that we've started with.